Hello, this is Dr. Lori. Welcome to this discussion on graphs in the real world. So as we're going through this topic, I want you to hold one thing in your mind, and that is the purpose of making a graph. Anytime we are creating descriptive statistics, and graphs is part of that, our goal is to convert data, all those individual little points of information, into a more collective information that can be used by a stakeholder to make some kind of a decision. And stakeholders can be a really wide variety of people. They can be who you normally think of as stakeholders, but then they can also be the recipients of the data, the information. And so this is pretty broad. This is a really wide viewpoint. Another way of putting that is graphs really need to convey your message. And so I'm going to give you 6 different pointers about graphs when you are looking at them, either already published in the literature or you are going to make them, that will hopefully really help create those graphs in a way that those stakeholders can use them, that it will convey your message accurately, concisely, in a way that that information is transferred. So the first one is to keep it simple. And this applies to so many things in life, but especially with graphs, you want to avoid all of the clutter. You want to keep them nice and clean. You want them to look sharp. And I would specifically say keep them in 2 dimensions. Unless there's a really good reason not to. And we're going to see some examples of graphs that really need those 3 dimensions. The bars or whatever, it really helps to convey that information, but we don't want to use it unnecessarily. The second one is the graph should be able to stand alone. And by stand alone, what that means is it should have all of the information on the graph that you need to understand what the graph is showing you. In other words, you shouldn't have to go to the text to figure out what the different groups are. If it's a grouping variable, you shouldn't have to go someplace else in the article to find out what the graph is showing. Everything on the graph should be labeled. It should have an accurate header. Typically the title of the graph tells who, what, when, and where. And often, even if the article has references, the table itself will say what the sources are for the data, because sometimes graphs are just lifted all by themselves. And so all of that kind of information, if you have abbreviations in your graph, you really need to identify what those are. So it needs to be able to stand alone so that the stakeholder, whoever it is, can just look at that graph and they know what it means. Part of the reason that this standalone is so important is the way people tend to read articles and reports. So first of all, they tend to glance at the very front, maybe read through the abstract, maybe kind of like leaf through things, but then they tend to be drawn to the pictures. A lot of people are very keyed into visual, and so if the graph itself has missing pieces, then that can be problematic. The third thing is scale, and by scale I'm talking about typically the y-axis. Often we'll take a y-axis, and if it's supposed to start at 0, 1, 2, 3, 4, 5, 6, if our graph is all happening up in this range, we'll get rid of these lower levels so that it actually looks like those peaks and valleys are actually much taller than they are, because the bars that are happening down here are really cut. So you just need to be very, very clear about labeling that y-axis if that's what you do, or to consistently not cut that. It can make a total difference in the way that graph is interpreted by a layperson if they don't understand that that axis has been cut. The other one is aesthetic and balance. And for this reason, a lot of times we will center things. We want to keep as few words as possible. So if you're thinking about the title to a column or the title to a subgroup within your graph, try to keep that as condensed as possible. And so that can really help the aesthetic look of your graph. The fifth one is color. And when used correctly, color can really, really help to convey your message, because you can do a lot with color that otherwise it would take a lot of information to try to kind of like get somebody to really understand what parts of the graph go together. Make sure that you use color in a meaningful way, and there are times when we know that our graph is not going to be always seen in color. Maybe there are some times that that color is going to be converted to black and white, and so you have to think about how that's going to copy. For that reason, when we use color, often we'll also use kind of a background shading to keep it meaningful. Because if we don't use that shading, if we copy in black and white, we just get shades of gray, and sometimes they're not different enough from each other for us to tell which ones go together. And finally, this is probably one of the most important things to keep in mind, but it can be one of the things that we forget about, and that is to use the correct graph for whatever variable type. Now, in published literature, this is not often something that they get wrong. You won't often see a graph that's inappropriate, a bar graph, when it should be a histogram, or vice versa. But there are areas of gray, and so always keep in mind that there are different ways of using different kinds of graphs. So if you come across one that seems like it's incorrect, just be really careful about assuming that it's wrong, but then also you have knowledge that maybe you could help somebody do something a little bit better. So I want to go to our CPH content outline and just kind of tie this into what we're doing. So this entire lesson really is talking more in depth about graphs. So we've looked at evidence-based approaches to public health number 4, applied descriptive techniques commonly used. And we're going to continue doing that throughout the quarter. But on top of that, we're going to be layering a couple of different things. So not only are you learning how to make the graphs yourself, but you're also learning how to interpret what other people have done. So number 1, interpret the results of statistical analyses found in public health studies or reports. So if somebody else has made the graph, then your job is also to be able to interpret their graphs. And number 5, identify some of the limitations of these research results or data sources or other things. And so to be able to interpret it and then also be able to layer on that what could be some of the limitations. So let's take a look. Oops, I did intend to keep that one. Here we go. Let's take a look at a report that someone else has published, and I want you to think about those 6 things that I talked about. Keeping it simple, being able to stand alone, being mindful of scale, the balance, looking at color, and making sure the correct graph was selected for that particular thing. We're going to be looking at the 2016 annual morbidity report, and here's a piece of terminology. Some people don't know what morbidity means. Morbidity means being sick, versus mortality, which is when a person dies. So mortality is death, but morbidity is the illness piece of it. And often with morbidity, we're looking at incidence. In other words, somebody newly coming down with something. So incidence versus prevalence is how many people already have that. So this morbidity report is for the entire year. It's specifically the communicable disease section, and we'll be looking at this in the next video as well. And if you look at kind of the overall parts of this report, there's a summary of reported communicable diseases. So is a list of diseases that physicians and healthcare professionals are supposed to report. And then in section 2, we look at the incidence rates for selected diseases by mode of transmission. And so let's go ahead and take a look at some of these. I'm going to start with diseases transmitted by the fecal-oral route. This salmonellosis is not, it is, it's taking me directly there. Yay! Okay, so the way this report is set up is that there are 2 pages for each disease. And the first page often in the top left lists some important things about that infectious disease. And on the right-hand side of that same page, we get to see a summary of some of the important descriptive statistics for that particular disease. So on the top right, you see salmonellosis cases by race, ethnicity, and gender for San Bernardino 2016. Do you remember how I said often a graph is identified by the who, what, when, and where? So the who in this case is the race, ethnicity, and the gender. And down at the bottom you can actually see the different genders form the rows. So the top row is female, the bottom row is male. Also all of the darker blue columns are going to be female and the lighter blue are going to be male. And then across the graph we get the different race ethnicities. So that's who we're really wondering about. The what is salmonellosis. What is it that we're looking at? The when is 2016 and where is San Bernardino? We get a total sample size of 234 and you can get a sense of the race ethnic groups and the gender perhaps that is more affected by salmonellosis. The second graph really splits this out. The top 3 that are typically reported are white, black, and Hispanic, and often we'll put the most common group in the back row just so that they're a little bit easier to see instead of being hidden behind the columns in the front. And then this third graph really gives us a sense of how this goes through in terms of the annual season. For salmonellosis, we do have something of a season where it's lower in kind of the winter and early spring, and then summer and fall it peaks through and then goes back down. And so it talks about how this kind of cycles through. We see 2014, 15, and 16, and we can see if we're having something out of the ordinary or if the particular pattern that we had this year was pretty typical. And then the second page gives numbers, numeric information back 10 years. So we get all the way back to 2006 so we can see if the pattern we're seeing now has really changed a lot. And then we also have another table by age. We'll talk more about tables next week, but then at the very bottom we get to compare San Bernardino, which is in red, and here's our use of color. We have San Bernardino County compared to California overall, which is in green, and then the United States overall. So for this particular disease, for salmonellosis, we get the sense that San Bernardino doesn't have particularly an excess risk. In fact, it is sort of hovering right around that Healthy People 2020 goal, which is just below 12 cases per 100,000 in the population. So that kind of corrects for the difference that happens over time if the population is growing or shrinking. So hopefully this gives you a general sense of the kinds of things that we're looking for in different graphs. You could take a look at some of the other diseases. You can see the number of cases for certain things is quite small. The number of cases here total is 8 for this year, for the year 2016. And you also see over here on the left hand side sort of overview of 2016, kind of some key points. Notice specifically that they're bullet pointed. This is really an effort to go back to this concept that we want to make this in a way that our stakeholders can really use this. If we gave big long paragraphs and made it look like it's hard to read, then people would be much less likely to be able to get that information out of the graph or the page. So they've really done an excellent job condensing this information into a way that people can use it. Thank you for joining me, and the next video will talk more about how this fits into the whole research realm.